Okay, guys, this is section 1.6 for honors pre-calc. This section should be pretty easy, guys. We're talking about transformations, our shifts, vertically, horizontally, our stretches, our shrinks. Okay, so this video shouldn't take very long. The first slide basically just talks about what we're trying to accomplish. We want to be able to algebraically and graphically represent translations, stretches, shrinks, and reflections of functions and parametric functions. Okay, you guys know what translations are. We don't need to talk a whole lot about that. Shifts them horizontally, vertically. So let's talk about what horizontal is. Again, guys, we already know the horizontal translation's inside the parentheses. So if you take the basic function x squared, if you shift it to the right 3, okay, that means you're going to get a minus 3, so this is right 3. If you shift it to the left 3, it's going to be plus 3. So I know that's sort of a change in what you might think. It's sort of the opposite of what you would think there, but x minus 3 in the parentheses really means you're going right 3. X plus 3 in the parentheses means you're going left 3. That is a horizontal translation. If it's outside the parentheses, or it's after the, in this case, x squared, your translation is going to be vertical. Now, the signs for vertical stay true to whatever the sign is. So in other words, plus 2 means up 2. Minus 2 means down 2. Okay? And you can see in the graph what happens. Now there's a helpful hint at the bottom here. If you want to remember the difference between horizontal and vertical translations, think add to the x, go left, add to the y, go high. Maybe that's something that you guys will help you guys to remember. But again, we did these last year. We've done shifts, geometry, we did them. So this is not a big new thing for us. So for this example, we have one of our basic functions, radical x. So what happens to part A? Well, the minus 3 is not underneath the square root sign, so we go down 3. Okay, and in part B, plus 3 is now inside the square root sign, so that means we have a horizontal shift. And remember, it's the opposite if it's inside, so this plus 3 really means we're going to the left 3. So we're taking our whole graph, and in part A, we're shifting it down 3. In part B, we're shifting it left 3. Okay, it says to take the graph of y equals x squared, another one of our basic functions. It's the black colored graph. There's a black and a red. Now you're not going to see that in your slides, but you can see it in here. They're going to show you a shift. They want you to write an equation for the red graph. So as you can see in part A here, the red graph is shifted to the right 2 units, I believe, if I count correctly. So there's the vertex, 1, 2. Okay, so it is a shift to the right 2. That means it's a horizontal shift, which means it's x minus 2 squared. For part B, we have a shift up of 1, so we're not going to have parentheses. Okay, only in horizontal shifts do we have parentheses. All right, so in a vertical shift, it's going up 1, so the sign stays true. We're going up 1, so it's x squared plus 1. Now in part C, 2 things happen. We have a horizontal shift and we have a vertical shift. All right, so we are going from the vertex of this graph, 1, 2, 3, I believe that's 4. So we are going to the right 4, pardon my chicken scratch, and down 2. Now we have a vertical and a horizontal shift. The horizontal shift gets taken care of by the parentheses x minus 4 squared. We're going down 2, so that's a minus 2 on the outside. So again, just a couple examples to show you guys when they show you graphs like this how to write the equations. It's very simple. We've done this before. Reflections, if you reflect across the x-axis, okay, you're literally just changing the sign of y. Same x values, except now y, all the y's flip signs. If you flip across the y-axis, okay, the y's stay the same. It's the x's that change signs. Okay. So when they ask you to find an equation for the reflection of this function, okay, across each axis. So across the x-axis, literally all we're going to do is we're going to just change. So we want to write negative f of x because that's really what we're doing, right? If you go back, across the x-axis was y equals negative f of x. That's the result of our reflection, okay, as we go back. So literally we're just going to do negative this fraction. Okay? So what happens is we can take the negative and sort of apply it to the top, so it would look like negative 5x plus 9 over x squared plus 3. It should be a plus sign. All right. Now you might say, well, why don't you change the bottom? Well, the negative is only going to go to the top or the bottom, because if the negative went to both, okay, the negative divided by negative would be positive. You'd be right back where you started. So when you have this situation, just take the negative and bump it to the top, change all the signs in the top, and you've done your job. Okay, so that's the new function. Now across the y-axis, it's going to be f of negative x. So now what we're going to do is we're going to take negative x and plug it in for x. Okay, so what's going to happen is we got to simplify this. So I have negative 5x minus 9. Now negative x squared is just x squared. Okay, so in this case, all right, only the actually the negative 5x and the 5x and the 9 both change signs. So you can see that when you reflect across the x-axis, all you're doing is you're just taking the opposite of the function. When you're reflecting across the y-axis, you're actually physically plugging negative x in for x and then simplifying from there. The vertical stretches and shrinks. Guys, it's real simple. If you have a number out in front of x squared, if that number is bigger than 1, as you can see, this graph is thinner. Okay? If the number in front of x squared is between 0 and 1, so it's a half, a fourth, 2/3, stuff like that, your graph is going to be wider. Now again, when in doubt, you can obviously graph it on your graphing calculator and it will show you whether it's going to be thinner or wider, but to save you time, you should know the rules for the numbers in front of x squared, or any graph, square root of x, absolute value of x, whatever, it's the same rules. The horizontal stretches, okay, actually one thing I want to go back, take a look at this right here. That's the rule for a vertical stretch. So when it says to do a vertical stretch or a vertical shrink, you're actually going to take the number and you're going to put it out in front of the function. Here's the difference. In a horizontal shrink or stretch, you're actually going to take the factor that it's being stretched or shrunk by, and you're going to put it inside the parentheses, and it's going to be x divided by that factor. So for example, when you have a curve that's like this, all right, they want you to find the equations for the transformations of L1. Well, it says that L2 is a vertical stretch of L1 by a factor of 3. Vertical stretch. That tells us that we have to do 3 times f of x. So that means you got to take 3 and you got to multiply by x to the third times 16x. So when you distribute, you get 3x to the third minus 48x. Okay, that's not a negative sign. That's just the end of the parenthesis. Now, the horizontal shrink by a factor of 1/2. So now you have to do f of x divided by 1/2. Okay, so when that happens, basically, f of x divided by 1/2. Well, x divided by 1/2, think about this. What's 1 divided by a half? It's 2. So you're really doing f of 2x. Okay, so what you do is you take that 2x and you physically plug it in for x in the function. So 2x to the third minus 16 times 2x. Well, that's 8x to the third minus 32x. So that's the function when you shrink it by a factor of a half. Okay, this is an important concept right here. Understanding that x divided by 1/2 really turns into 2x. And then that 2x is what gets plugged into the function. Okay, the vertical stretch is easy. Okay, you just take the number and you multiply that number by the entire function and you're fine. But the horizontal shrink, you're actually going to be plugging in something to each x in the function. Okay. Combining transformations, so we can do shrinks and shifts, stretches and shifts, reflections and shifts, all that stuff that we've done before. Want to take you, I kind of went out of order, but example 5 talks about the quadratic parent function. Now guys, the quadratic parent function is y equals x squared. Okay, quadratic means x squared. We have to do these transformations in order. So they want us to find the equation that results. So y equals, now it's a horizontal shift of 2 to the right. So 2 to the right means x minus 2 squared. Okay. Vertical stretch by a factor of 3. So now we take that and we multiply by 3. And then the vertical translation of 5 units up, we put a plus 5 at the end. Okay. So it's literally that simple. They're telling you to go in order, so you have to do these in order. Okay, so this is our equation after all of our shifts and stretches. Now the next one says to go in the opposite order. Okay, it tells us to go in the opposite order. So what happens is we have to take, now we're doing this, we're going backwards. Okay, so now we're doing the vertical translation first. So first thing we have to do is the plus 5 first. Now we have the stretch. Now we have the shift. Watch what happens. Okay? Because we reversed the order, now that vertical stretch of 3 affects this entire equation. Whereas in this one, it only affected the horizontal stretch, or the horizontal shift, excuse me. Okay, so notice how the order of the transformations matters there. Okay, now you can distribute if you want. What I would do is I would just kind of distribute like that. So it would be 3 times x minus 2 squared plus 15. If you want to FOIL out x minus 2 squared and you want to then multiply by 3, if you really want to put this in standard form, you can. Personally, I would just leave it like this. I would just do that because it's going to be a lot easier for you to write and it's a lot less for you to remember. Alright, I want to go back to this slide. What I underlined here, when you're dealing with a graph, okay, with the equations it's easy, you just go in the order that it tells you. But when you're dealing with graphs, like this example right here, what you want to do is you do stretches, compressions, and reflections first, then do the translations. So here we have a vertical stretch of 2. So that means that this point right here gets doubled. Whoops. Okay. So now this graph goes up here. So we've stretched it out by 2. Okay. Now, we shift to the right 1. So now, this point here is shifted to the right 1. This point here shifted to the right 1. All the points are shifted to the right 1. And then we go up 2. So this point right here goes to the right 1 and up 2. Whoops. Okay. Now this point, which was stretched, goes, that point was at 2, 4 when it got stretched. Okay, so now it shifts right 1, up 2. The point at 0, 0, right 1, up 2. Okay, now let's see. So this sort of goes off the tracks here. Okay, whoops. Pick the pen. There you go. Alright, so this point was -1, -2. So now we go right 1, up 2. Okay, so I think -2, -3, up, right 1, up 2. So I think it, actually no, it doesn't do that. So our graph looks like that. Actually, there's no arrow at the end. Okay, so all you're doing is you have to do the stretch first and then do the translations. Okay, just don't erase it. There we go. So that's the rule. Alright, so when you're graphing it, it's not that big of a deal. You just have to do this first, then do your shifts. Okay, we'll go over more about this in class tomorrow, but this is the basic idea for section 1.6.